This is Environmental Science 2, Chapter 7, Part 1 on Atmosphere and Climate. In this portion of the video lecture, we will be discussing the layers and structure of the atmosphere, as well as factors that affect climate. The atmosphere is a thin layer of gases that surround the Earth. They go up quite a few miles. There's more to the air up there than just what we breathe in down here by the surface. The atmosphere helps protect the Earth from some of the ultraviolet radiation that comes from the sun. The sun provides us with heat for infrared. It provides us with visible light, of course, so we can see. And then it also has ultraviolet radiation, which is in the part of the electromagnetic spectrum that we cannot see, but we still can feel the effects of ultraviolet radiation. Very early Earth atmosphere, before there was life on the planet, there was very little free oxygen molecules. Free oxygen meaning usable oxygen that's not locked up with another element. The early atmosphere was mostly methane, water vapor, sulfuric gas, and ammonia, mostly coming from the outgassing of volcanoes. As the Earth was cooling, those gases were being released into a very early atmosphere. Once we fast forward the Earth time clock quite a few million years, eventually we have bacteria and algae that are able to take chemicals out of their environment along with the sun and make their own food. So they started to photosynthesize. And of course, the byproduct of photosynthesis is oxygen. So free oxygen was put into the air very slowly over the next millions of years. A few bacteria can't produce many free oxygen molecules, but if you get billions and billions and billions and billions of them doing this process all the time, we can slowly start to build up that layer of free oxygen in our atmosphere. So let's take a look at the anatomy of the atmosphere, if you will. We'll start from the surface and then head on up out into space. The troposphere is the layer of atmosphere that's right near the surface. It goes up about 10 kilometers or 6 miles. Most of the atmosphere's gases are contained in this layer. It's the heaviest layer, which is why it's near the surface. This is the layer where all of the weather occurs. The stratosphere is our next layer of atmosphere. It leaves off where the troposphere was at about 10 kilometers, and it goes up to about 45 kilometers. The stratosphere has very thin air and very low air pressure. Stratosphere is generally where planes tend to fly because you want to get up and above what they call the cloud deck. You don't want to be flying large aircraft in weather if you don't have to, so flying in the stratosphere is where most aircraft are. The stratosphere also contains the ozone layer, which we will discuss further in this chapter. The mesosphere is the middle sphere of atmosphere. It goes up to about 80 kilometers. And we're about halfway through all the 5 layers. The mesosphere is where a lot of the communications satellites for things like GPS and internet, cell phones, are found in this layer. So again, you want to get up and above all of the weather so you don't get interference from that. And this way, we can have the clear communication signals from those satellites through the layers of the atmosphere to the Earth's surface. The thermosphere is our next layer up. It goes up to about 500 kilometers. It's a very thick layer of atmosphere. We call it the thermosphere because oxygen molecules that are there will actually absorb ultraviolet rays, and the thermosphere is the only layer of atmosphere where there's a temperature increase from the bottom to the top. Now, don't get me wrong, the temperatures are still very, very, very cold up here, but throughout the thermosphere there is a temperature increase because these oxygen molecules absorb ultraviolet rays and they shake and they wiggle and they vibrate, which will increase the temperature. After the thermosphere, we have our last layer of atmosphere, which is basically kind of the boundary of outer space. So the exosphere is kind of the rest of the atmosphere on out to space. So in general, when we take a look at the layers of the atmosphere, again, the troposphere, that's where all the weather occurs. The stratosphere, that's where planes tend to fly. The ozone layer is also here. The mesosphere is the middle sphere where our communication satellites are orbiting. And the thermosphere is where we have oxygen molecules absorbing ultraviolet rays. And then the black part up there on the top would be considered the exosphere. So now that we know a little bit about our atmosphere, we can talk about weather and climate. Sometimes those terms are used interchangeably, but they do mean very different things. The weather is the daily occurrences of things. So it's the daily precipitation, wind speed, humidity, the day-by-day things. Once you start to average your daily weather, then you can develop a picture of the climate. So that climate is an average weather pattern over a very long period of time. So what determines climate? Quite a few things. Latitude can affect climate, as well as air circulation, ocean currents, and the local geography of a region. Latitude is how far a location is north or south of the equator. And because the Earth is tilted on its axis, we have angles of sunlight that will be different spread out over the surface of the Earth. More intense sun rays are found at the equator, whereas more weaker sun rays are found at the poles. So the angle of the sunlight will determine the surface temperature. Basically, no matter what season it is anywhere on the planet, there is always warmer conditions climate-wise at the equator than at the poles. The Earth is unequal or unevenly heated, and that causes global air circulation because hot air rises and cool air sinks. And so hot air will rise at the equator and tend to sink at the poles. So that gives us a nice global air pattern of circulation. Your proximity to oceans can also affect climate. Oceans are a great holder of heat for water. So ocean currents are also moved by these global wind patterns. Coastal areas tend to see a more mild or humid climate because of the proximity to that large body of water. And of course, local geography can affect climate as well. Altitude is one of those factors that can affect climate, as well as mountains or large bodies of water. So the climate in an area that are near these things can be very specific, whereas outside of the mountain range or very far from the body of water, the climate can be very different. Now remember, seasons have nothing to do with how close or far the Earth is from the sun. We are actually closer to the sun distance-wise in January than we are in July. The reason why we have seasons on this planet is because the Earth's axis is tilted at 23.5 degrees and our orbital pattern around the sun. So we have our different equinoxes for the fall and spring, and we have our solstices for the summer and the winter. This has been Chapter 7, Part 1 on Atmosphere and Climate.